Hello everyone, welcome back to my channel. I hope you're doing great today. Now in today's lesson, we're going to look at a brief introduction to SQL. My name is Timipre Godgift, an Oracle Certified Database Administrator, and I'm excited to take you on this course. In this course, I will hold your hands practically and we'll walk through the fabrics and fiber of SQL. This course promises to be 100% practical. So get ready to get your hands dirty as we take on this journey of SQL. Now, before we delve into the course properly, let's have some basic knowledge. Let's have some basic foundational information. Every business has a requirement, and that requirement is information. The information could range from details of employees in a company or product description details. It could also be details about the company's organization structure. All of these details are called data. These data could be stored on a computer for easy retrieval and easy manipulation. Now, by manipulation, I mean adding, modifying, and deleting data that are no longer needed in the computer. These data could be stored in form of text, numbers, pictures, and sound. In time past, we had traditional applications like Excel that tried to do a good job by organizing data. However, they had quite a number of limitations. Some of these limitations are listed below. One limitation is the issue of data integrity. Now, if you've worked with Excel before, you'll agree with me that even if you define a particular column as a text column, you could actually store numbers in those columns. This in itself is a serious limitation. Let me show you what I mean by this. Now, this is our Excel worksheet. And then for this particular column, we've assigned a text data type. But trust me, I can type a name, which is text-based, and at the same time, I can type a number. So you can see that there is no integrity in the data field. So this is why database management systems were introduced. So let's go back to our lecture. Another limitation of Excel is the issue of data consistency. Now, you cannot make a change on Excel and then it becomes visible to everyone in real time, assuming people want to access this data. Okay, it cannot be visible to everybody in real time. And then there's the issue of limited data set. As your organization keeps growing, your size of data will keep growing to the point where you start having billions and billions of rows of data. Excel cannot handle this expansion. And then also there's the issue of lack of automation. These are all of the things we're going to cover when we start talking about database management system. Another key concept I want us to look at is data models and database design. I know you'll be wondering, this course is supposed to be about SQL. Why are we talking about data models and database design? Well, the reason why you are learning this course is so that you will be able to interact with a database. For you to get information from any database, you need to know SQL. So that's why you need to also have an idea of data models and database design. Because if you don't know how the design of a database works or the design of a database is, how can you effectively get your information? How can you query this information? So what are data models? Data models are used to describe business entities and relationships. These models contain entities, attributes, constraints, and relationships. Now, it's very important that you take note of these words: entities, attributes, constraints, and relationships, because we're going to talk about them in details in the coming slides. Now, the next thing you should know is these entities eventually become tables in the database. Tables actually store your data in forms of rows and columns. Now, the data model is also a logical structure for designing and creating your database. It is used to represent the data and how it is stored in the database. Another thing you need to know about data models is that there are actually 4 types of data models that are used to design a database. The first one is the hierarchical model. The second one is the network model. The third one is relational model. And the fourth one is the entity relationship model. And this is what we're going to be considering for this course. The entity relationship model uses the entity relationship diagram. This is a commonly used data model for database design. Now let's look at the entity in details. An entity is simply a real-world object with a set of properties that makes it easily identifiable. For instance, a customer is an entity. A product is also an entity. What are attributes? Attributes are actually the properties of an entity. They describe an entity and differentiate one entity from another. For example, we have the name, we have the address. Every customer must have an address. Every customer must have a name. So the name, the address, the phone number of the customer are all attributes of that entity, customer. I hope this is getting clear to you. Now, the next thing we want to talk about is the relationship. The relationship refers to the association among entities. What actually connects different entities together is what is known as relationship. And this is very essential when creating your database design. If you look at our diagram, you'll observe that the entity customer and the entity product are related by orders, which is the relationship. So in clear terms, every customer must order a product. So in this case, order becomes the relationship between the two entities, customer and product. And then we have to look at constraints. What are constraints? Very simple. Constraints are certain rules that are enforced on the data columns of a table. They are used to limit the type of data that can go into a table. What this does is to guarantee the accuracy and reliability of data in the database. Now, if you look at the diagram below, you'll see that we already have 3 tables. Remember, we mentioned previously that these entities end up becoming tables in the database. And then we also established that relationship can also become tables in the database. So if you look at these 3 tables, for the customer table, we have what is known as customer ID, and we have other attributes of the customer. If you look at the product table, we have a product ID and other attributes of the product. If you look at the other tables as well, we have order number, date, and other attributes. Now, let's look carefully. What is the relationship between the customer table and the orders table? The customer table has what is known as a primary key constraint. Now, this constraint ensures that no duplicate values are entered into this ID column. In other words, you cannot have 2 customers with the same customer ID, and then the same customer ID is seen in the orders table. So in which case, the customer ID in the orders table becomes a foreign key. This is because it references the customer ID in the customer table, which is a primary key. So it makes it easier to be able to select data from the 2 tables simultaneously. For you to be able to select data from 2 or more tables, you need to be able to connect those tables with a single column that is common to both of them. Now, one table is supposed to be making reference to the other table using the customer ID. The same thing if you look at the product table, you have product ID and then you also have product ID in the orders table. So it means you can actually select data from the 2 tables simultaneously using the primary key as the common factor. Now, this is an overview of the HRO schema. The HRO schema is the default schema that is found within the database after installation. A schema is simply a collection of database objects like tables, views, triggers, functions that are all related. So for you to be able to learn SQL with Oracle, Oracle recommends that you learn with the HRO schema. So it's only important that we introduce the schema design to you so you get familiar, you get acquainted with how the HRO schema was designed. Now, if you look at the employees table and the departments table, you agree with me that there is a relationship between these tables. Okay, you have employee ID, you have other attributes of the table, and then you have department ID, which is actually a foreign key referencing the department ID in the departments table. Now, the department ID in the department table is the primary key. So if I need to select data from these 2 tables, the common feature that will connect this table is the primary key. Of course, we know that every employee must work in a department. So let's say employee John works in department ID 90, and I don't know the details of department ID 90. The only place I can get the complete details for department ID 90 is actually in the departments table. Again, if you look at the job history and the employees table, we have a primary key column here, employee ID, which has become a foreign key in the job history table. So in a nutshell, this is just what constraints help you to do. They ensure the integrity of data. They ensure that no duplicate values are stored in the table. They ensure that the right type of data actually goes into any table that will be stored in the database. By the time we start our practical lecture, we will probably explain the different type of constraints and what they do. Database concepts. A database is an organized collection of logically related information stored electronically in a computer system. In a database, data is stored as tables, and tables maintain data in rows and columns. The process of maintaining databases to ensure that information is readily available is known as database management. And then the software required to perform the task of database management is what is known as Database Management System, or DBMS. DBMS are designed to maintain large volumes of data. They ensure the data is stored in a systematic and orderly manner. They also help users recover data during system failure. There are basically two types of database management systems. We have the Relational Database Management System, or RDBMS for short, and we have the Object Relational Database Management System, or RDBMS. The Relational Database Management System is actually a collection of related data. Each attribute is considered as a column, and each record is considered as a row. A table can be related with one or more tables based on a single column or multiple columns. Okay, this is what we just tried to establish, when we're talking about constraints. Now, some examples of relational database management system include Oracle, Microsoft SQL Server, MySQL, SAP, DB2, which is owned by IBM. And then the Object Relational Database Management System integrates an object-oriented front end with Relational Database Management System. And Oracle is also an example of Object Relational Database Management System. But one thing is common to both the Relational Database Management System and Object Relational Database Management System. And that common thing is the fact that they both make use of SQL. And this is what we are here to learn in this course. So what is SQL? SQL, or SQL as it used to be pronounced, is actually an acronym for Structured Query Language. And this language is a standard programming language with English-like commands that is used to access and manipulate data in a database. It's so easy to understand, it's so easy to learn because the commands are written in English readable form. Now, to write your SQL statements, you need a development environment. And the two common development environments we use to write SQL statements are SQL Plus, which is a command line tool, and the SQL Developer, which is a graphical user interface. The two pictures show you clearly the difference between the two development environments. Okay, this is SQL Plus, which is a command line interface. And then this is your SQL Developer. But for this course, we will be working more with the SQL Developer. There are different types of SQL commands. We have the data definition language, and under it, you have statements like create, drop, alter, and truncate. You can use the create statement to create a table. You can drop a table with the drop statement. You can alter a table. You can truncate a table. And then we have the data control language. Under this, you have statements like grant and revoke. Grant a privilege and revoke a privilege. Then we have the data manipulation language. Under this, we have your insert, update, and delete. We also have transaction control language. And under it, you have your commit, rollback, and save point. And then you have your data query language, which is your basic select statement. Thank you for listening to this presentation. If you have any questions or comments, feel free to shoot me an email or send me a WhatsApp message on the numbers displayed on the screen. I'll see you in my next video. Bye for now.